We have a lot to learn today, so let's get started with the distributive property. Okay, I want you to try these problems and I want you to notice something. So, first I just want you to do 5 times the quantity 2 plus 8. And then I want you to do 5 times 2 plus 5 times 8. Then I want to see if you can do 7 times the quantity 3 plus 6. And then I want you to break it up to 7 times 3 plus 7 times 6. And then I want you to try 2 times the quantity 4 minus 6. And then 2 times 4 minus 2 times 6. Okay, now would be a good time to pause and try these. Then I'm going to work them out real quickly. Here you should have 5 times 10 and get 50. You should have 10 plus 40 and get 50. In the second one, you should have 7 times 9 and get 63. Here you should have 21 plus 42. That still equals 63. Here we want, in the next one, 2 times negative 2. Sorry, 2 times negative 2, which equals negative 4. And here we should have 8 minus 12, which also equals negative 4. So, make a conjecture. Based on this, we're always getting the same thing. A times the quantity B plus C, what do you think is going to be an equivalent way to write that? Okay, we'll look at that on the next slide. Okay, the distributive property, it's a property that allows us to simplify problems like you just saw and write them in a couple different ways. For every real number, A, B, and C, it is always true that A times the quantity B plus C equals the same thing as A times B plus A times C. This also works if you have A written after, because remember multiplying can be in any order, so the quantity B plus C times A, that could equal B times A plus C times A. And this also works when there's subtraction in the middle of the parentheses. So A times the quantity B minus C, it equals AB minus AC. And B minus C, that quantity times A equals BA minus CA. This comes in really handy when you want to try to solve some problems with mental math. If I ask you to solve a problem like 15 times 102, and you were doing that in your head, you might not know, but you are probably using the distributive property when you solve it. Go ahead and try it and see if you are. So if I ask you to do it in your head, just solve that on your own. You probably did 15 times 100 in your head, and you probably did 15 times 2. And you notice this was 1500 and this was 30. And then you probably added those to get 1530. So you used the distributive property even though you didn't know you were using the distributive property. You took this 15 and multiplied it by 100 and then by 2. A lot of people don't know that you can use it with problems like this as well. 13 times 98. You can think of that as 13 times 100 minus 2. So if you distribute, I like to use these like little arrows. You could do 13 times 100 minus 13 times 2, which would give you 1300 minus 26, in which case you could have 1274. And that's something you might be able to do in your head just by knowing that 98 is 2 less than 100, making it an easy number. Okay, see if you can get either of these last two problems and then I'll work them out. Try to do them in your head using a good shortcut. Okay, I'm going to look at 21 times 9 and 99. I'm going to think of that as 21 times 1000 minus 1, which means I'm going to do 21 times 1000 minus 21 times 1. So I've got 21,000 minus 21. And so now I just have to think, okay, if I'm going to try that in my head, what is it? And it is 20,979. Okay, and then this one, find the total cost of 4 CDs that cost $12.99 each. I'd probably think of that as 4 times $13 minus a penny. So 4 times 13 minus 4 times 1 cent. That's going to, oops, 0.01. Sorry about that. 0.01. There we go. So 4 times 13, that's 52 minus 4 cents. That's going to be $51.96. Okay. All right. let's look at simplifying expressions that aren't just numbers, because this is probably even more common. It's a very much a building block of algebra, working on skills like this. So if we use the distributive property to simplify 2 times the quantity 3x plus 7, we need to remember our rule was a times the quantity b plus c. That equals the same thing as ab plus ac. So here I'm going to take this 2, which is outside the parentheses, and I'm going to multiply it by each part that's in parentheses. So this is going to be the same thing as 2 times 3x plus 2 times 7. And we want to simplify this as much as we can. 2 times 3x, we usually write that as 6x. 2 times 7 is 14. So we have an answer of 6x plus 14. 6x and 14, they're not like terms, which we'll talk about later, so we can't add them. And 6x plus 14 is our final answer. Okay. When we look at this one, 5x plus 6 times negative 2, even though the negative 2 is at the end, it's still what's multiplying both things. So we could write this as 5x times negative 2 plus 6 times negative 2. And I would just multiply this out. So 5x times negative 2 is negative 10x. Plus 6 times negative 2 is negative 12. So you can write negative 10x plus negative 12, or you can write it as negative 10x minus 12, because remember, adding a negative is just like subtracting a positive. This one has one fewer sign, so I like it as my final answer. Okay, if we see this one, negative 4 times the quantity 8n minus 5, it looks similar here. So I'm going to do negative 4 times 8n, but this time I have a minus in the middle, so it's going to be minus negative 4 times 5. Okay, so then I'm going to have negative 32n minus negative 20. And again, because I have a minus and negative, it's fewer symbols if you just write that as plus a positive. So negative 32n plus 20 is a great final answer there. Okay, let's look at one more of these. You might see just a negative sign in front of the 5x plus 7. So this means the opposite of 5x plus 7. So I'm taking the opposite of everything in here. So I'm taking a negative times the 5x, which is negative 5x, plus a negative times the 7, which is negative 7. So here I will have negative 5x minus 7, or negative 5x plus negative 7. But again, one fewer symbol, I like to write it like this. Okay. There's a little bit of vocab that would benefit you to know it as you're working through the lesson. A term, that's just a number, a variable, or the product of a number and variables. And I hope you remember that term product, it means multiply. So if I have something like that, 8m, 3m, negative 7xy, 5n squared, those are all terms. They're just either a number or a variable, or numbers and variables multiplied together. Remember that n squared is n times n, so that's multiplied together. Constant is just a term that has no variable. So that means anything that's just a number, like the 8 above, we call that a constant. A coefficient is a number that multiplies a variable. So a number that's in front of a variable, or just multiplying a variable, like the 5 in 5n squared, that's a coefficient. Okay, so the 5 here is a coefficient because it's multiplying a variable. The 8 here is just a constant because that's just a number by itself. So constant by itself, coefficient multiplying a variable. When you know what terms are, we need to know what like terms are. Super important, double star, triple star, whatever you're going to do to make yourself say, I need to remember this. Like terms have the same variable or variables raised to the exact same power. To be like terms, you have to have both of those things happening. So I want you to look at these. Are the following sets of terms like terms? Yes or no? And then think about explaining here. So the first one, 6x and negative 8x. So you're looking for two things. Do they have the same variable, and are they raised to the same power? So if I'm looking here, let's just look here. They both have the variable x. You don't see a power there, so it's like an invisible power of 1. So we would say, yes, these are like terms because they have the same variable raised to the same power. Okay. Okay, so that's a yes. See if I can get it to work. There we go. The next one, 7x and 7y. If we look here, this one has the variable x, this one has the variable y, so they are not like terms. This third one, if we have 2x squared y and 5x squared y, we want to look at their variables. They both have an x and a y, and they also have to be raised to the same power. So this one's, the x's are both squared, the y's both are to the power of 1 because it's not showing. So yes, these are like terms. They have the same variable and the same power. Okay, and if we look at this last one, negative 3x and 3x squared. It might tempt you because those both have 3's in them, but if you look at them, this one has an x, this one has an x squared. They both have an x, but it's not the same power, so we would say these are not like terms. Okay, let's look at how we can combine like terms. So when you combine like terms, which means we're usually adding or subtracting like terms, you can think of the distributive property in reverse, knowing that BA plus CA equals the quantity B plus C times A. So I'm going to give you some expressions and I want you to simplify them by combining your like terms. So this one, first one, is 2y squared plus 8y squared. So if you wanted to, you could think of it in reverse, that this is the same thing as 2 plus 8 times y squared. And we know what 2 plus 8 is. That's 10. And our y squared just stays the same. So I usually don't do that middle step. I usually just go right onto the like terms and I think, okay, all I'm really doing here is I'm adding my coefficients, the numbers in front of it, but my variable and my power are staying the same. So we're going to look at the next one. So negative 2m minus 8m. You've got to be really careful here. If you wanted to show it out again, you could show that it's negative 2 minus 8 times m, and that's going to give you negative 10m. Or you could just think, what is negative 2 minus 8? That's negative 10, and the m is going to stay the same. Okay, 12x plus x. This one gets people a lot. 12x plus x. What might help you here is when you just see a regular x, there's like a little invisible number in front of the x. What is it? If you said 1, give yourself a high five or one hand to the other. That could be an invisible 1 there. So we've got 13x. That's as simplified as it can go. Okay, again, you could write that as 12 plus 1 times x if you like that middle step. Okay, the last thing you probably have to do in your classwork and in this lesson in general is learn how to write expressions using some of these words. So a key thing to know, vocab here, the word quantity, that tells you that 2 or more terms are within parentheses. So if I'm giving you a problem like this, write an expression for the product of negative 6 and the quantity 7 minus m. You should be clued into thinking, hey, 7 minus m, that's in parentheses. So when I'm writing my expression, I usually would start out with that. 7 minus m is going to be in parentheses. And then it's going to be the product of negative 6 and that whole quantity. So product means multiply. So I'm going to put it right out here. Negative 6 times the quantity, 7 minus m. I have my algebraic expression. Okay, I know this is a lot to digest in this lesson. Hopefully you come in prepared with questions and ready to work hard in class. We're still going to be working on our work. You can say it's not homework really anymore, but on our work without a calculator. Our next quiz will be a no calculator quiz, so remember we ought to practice like we play. All right, see you soon.